Here we're given a state test question of a proof where they're asking you to fill in reasons 3, 4, 5, and 6. So I'm going to talk you through the thought process to figure out what those reasons are. But first, let's talk in general about proofs. Proofs typically give you an image so you can visualize what's going on. They give you a piece of information that is true, sometimes more than one piece of information. So there's always a given. And then they're asking you to prove something. So you need to make yourself a 2-column proof like this, where one column lists all your statements and the other your reasons. And you always start off with the given. For each statement that you make, you have to give a reason. You make a statement, and in your head you should say, I can say this because it is given. For most of the statements in a proof, you use definitions, theorems, and postulates to justify your statements. So you go from this, and you kind of follow this path of logic from one statement to the next in order to ultimately get to your last statement, which is what you were asked to prove. So in this case, they've done most of the work for you. They've gone through that thought process, and you just need to figure out why they made these statements, why they could make each of these statements. So let's take a closer look. The first statement is what was given, that this is a parallelogram. Again, we can make this statement because it is given. Now, going from there, what do we know? If it's a parallelogram, what does that mean? Well, with parallelograms, the opposite sides are parallel. So these 2 blue lines are parallel, and these 2 pink lines are parallel. Parallelograms have 2 sets of parallel lines. So that's what they're saying here in statement 2. The reason I can make this statement is because that's the definition of a parallelogram. So notice here we have 2 sets of parallel lines. We also have another line here. This red line is called a transversal because it is cutting across those 2 sets of blue, or the 2 blue parallel lines. It's also cutting across the 2 pink parallel lines. So let's look at what it is saying in statement 3 about the angles that are created by that red transversal line cutting across those parallel lines. The first one is saying angle ZWY, so from Z to W to Y, that is congruent to XYW. XYW. So this angle is congruent to this angle. So let's take a look at these angles. How are they created? Notice that they both share this common side, and then the other side of the angle are those 2 parallel lines, the 2 yellow parallel lines. So these green angles are formed by 2 parallel lines and then this red transversal that cuts across it. So let's take a closer look. If you have 2 parallel lines, and then this red line is cutting across it, notice that these green angles are inside the 2 parallel lines. They're in between the 2 yellow lines. They're also on the opposite sides of the red line. So let's remember that. Now let's look at that other set of angles. From ZYW, and then XWY, XWY. So we're looking at this angle and this angle. So how are these angles formed? Again, they both share this common side, this red line in the middle, and then the other side of that angle, to form the angle, is this blue line. So these 2 green angles are formed by the other set of parallel lines, and then that red transversal. So again, let's take a closer look. Let's just extend our lines out. I have these two sets of parallel lines. I have this red transversal line that cuts across. Those green angles are in between the two parallel lines. They're inside the two parallel lines. They are also on the opposite sides of the red transversal. So what kind of angles are those? If we knew what kind of angles those were, and that those angles are always congruent, we could use that as the justification for making these two statements. So let's take a closer look at the angles that are formed by parallel lines when they're cut by a transversal. Whenever you have two parallel lines, like these two red parallel lines, and it's cut by this blue transversal, you get two sets of 4 angles. You see them? They're the same. Also, with these angles, we refer to them as interior if they're in between the two parallel lines, or exterior if they're outside of the parallel lines. And then the angles are either on the same side of the transversal or the opposite side of the transversal. Something else about those angles. Corresponding angles are always congruent. Okay, so these are sets of angles that are created by two sets of parallel lines cut by a transversal. So what are corresponding angles? Maybe the angles in our proof are corresponding angles. Corresponding angles are ones that are in the same spot. For instance, look at angle 1 and 5. They look the same size, right? Notice that they are both above the blue parallel lines and both to the left of the transversal. Or the purple ones, 3 and 7. They're both below the blue parallel lines and to the right of the transversal. They're in the same spot. They correspond to one another and they're always congruent. Here are two other types of angles that are formed that are congruent. When you have two parallel lines, here in red, and you have a transversal that cuts across it, the angles that are inside the two yellow parallel lines and on opposite sides of the transversal are called alternate interior angles, and they're always congruent. So were the angles in our proof alternate on opposite sides of the transversal and then interior inside the parallel lines? Another way that you can create congruent angles when you have two sets of parallel lines and again a transversal cutting across it are alternate exterior angles. So again, if they're on opposite sides of my purple transversal line and they're outside of my parallel lines, they're alternate exterior angles and they're congruent. So let's take a look again at our proof. Are the angles they're saying in that statement alternate exterior angles, alternate interior angles, or are they corresponding angles? What do you think with these green angles and these green angles here? Whatever you think these green angles are they corresponding angles, alternate interior angles, or alternate exterior angles? Pick one of those, and that would be your reason for being able to make this statement number 3. Once you make a statement, you want to label those angles or sides that they're saying are congruent, and then you move on to the next one. For statement 4, they're saying that WY is congruent to WY. That this line is congruent to itself. The reason you would make a statement like that is because notice that red line is a part of this triangle and it's also a part of this triangle. So you're basically saying that that red side length in the yellow triangle is congruent to that red side length in the purple triangle. And this is a very common statement that you make in proofs. If you ever have to say an angle is equal to itself, or a side length is equal to itself, or a segment is equal to itself, the reason you give is the reflexive property. A lot of people remember that because they think of reflection, the same thing on both sides. So if you mark that one, and again, visualize these two triangles because that's where we're going to next. They're telling you that in statement 5 that the yellow triangle is congruent to the purple triangle. Now some people, it's helpful to kind of sketch these triangles, kind of separate them and take a look at them a little bit more individually. There are a set of triangle congruence postulates that you can use to justify and conclude that triangles are congruent. And you really just need to know 3 pieces of information, 3 sets of congruent angles and sides. So in order to figure out which of those postulates we would use, or theorems we would use as the reason to conclude that these 2 triangles are congruent, I'm going to review that, but let's take a look here at what we have already decided are congruent in these 2 triangles. Notice that they both have 2 sets of congruent angles, and then 1 set, that red line, of congruent sides. So 2 sets of angles, and then that side that's in between the 2 angles, that connects those 2 angles. So let's look at a couple of those triangle congruence theorems. This is just a few of the triangle congruence theorems. Let's pick out which one works for this proof. So if you go through a proof here in the orange, and you're able to say that this side on this triangle is congruent to this side, and this side is congruent to this side, and this side is congruent to this side. So we have 3 sets of corresponding congruent sides. Then you can conclude that the triangles are congruent because of the side, side, side theorem, or SSS. Is that the one used in this proof? Or if you look at the one here in the green, if you go through the proof and you're able to say this side is congruent to this side and our 2 triangles, this side is congruent to this side, and then this angle in between the 2 sides are congruent. Then you have enough information to conclude that these 2 green triangles are congruent because of the side angle side congruence theorem. Notice the angle is in between the 2 sides, and the same in the wording. And then the last one I want to go over is angle side angle. So if you're able to go through your proof and say this is congruent to this, and then this is congruent to this, and then the side in between those 2 angles are both congruent. Then you can conclude that these 2 blue triangles are congruent because of the angle side angle congruence theorem. Notice the side is in between the 2 angles, and the same for the wording. So which of those theorems works for your proof? That is the one that goes right here. Now that you have concluded in your proof that this yellow triangle is congruent to this purple triangle, now they're just making the statement that WX is congruent to YZ. Why can they make that statement? That wasn't something that we talked about through any of these steps. Okay, this is the last thing you need to know. If you go through this proof and you get those 3 pieces of information, those 3 corresponding sides or angles that you have proved are congruent, and you decide these triangles are congruent. Once you do that, you can make a statement about any of the other angles and sides in the triangle being congruent because of the corresponding parts of congruent triangles are congruent. So I can make the statement that because these 2 blue angles, these 2 corresponding blue angles are congruent, and that white side that I have marked is congruent, I can now say that the other sides are congruent as well, and the other corresponding angles are congruent as well. Once you go through the steps to find out that two triangles are congruent, you know that all of the corresponding sides and all of the corresponding angles are congruent, and you can make that statement in your proof, and all you need to do is say CPCTC, corresponding parts of congruent triangles are congruent. And so that's what you would put right here in line 6.